Welcome viewers to my lecture on computer numerical control machines. In any modern manufacturing system like flexible manufacturing system, computer aided manufacturing systems, primary building block is CNC machines. So, from the production point of view, this accuracy and precision of the CNC machine is far better than the conventional machines. Let me first define what is CNC machines. First, I will define a machine, then what is numerical control and why I have integrated computer with numerical control machines. What are the benefits I am expecting from this by integrating computer? First, machines. A machine is a mechanism comprising of two or more than two links which converts any other form of energy into mechanical energy. Now, what is any other form energy? If this energy is electrical energy and the machine converts electrical energy into mechanical energy, then it is electrical machines. If hydraulic energy is used and it is converted to mechanical energy, then it is hydraulic machines. Now, let me quantify this. What is mechanical energy? Actually, mechanical energy two types we call, one is potential energy, abbreviated as PP, plus kinetic energy. Kinetic energy abbreviated as Ke. As you know, this is quantified as mgh and this is quantified as half mv square. Now, in a machine, this potential energy not changing. So, I can consider it is a constant so as to m is constant. So, ultimately what happens, I am creating some velocity of the some parts in the machines. That velocity may be linear or may be rotational. Of course, if it is rotational, then I can quantify this as V is equal to W r omega r. So, this velocity is used for to getting some work. This energy is converted into work in machines. Now, there are various types of machines. Let me discuss first. So, as for example of machines, that may be sewing machines, and grinding machines, and the machines which we are seeing in our workshop, that may be lathe, milling, drilling, shaping, and so on. All these are machines, but if you see these machines, function of these machines and functions of this category of machines is completely different. In which way it is different? These machines are used to reduce materials from a blank. That means it is used for some metal removal functions, whereas this type of machines does not do this type of work. Okay. To distinguish these two types of machines, this type of machines is called machine tool. If I want to see pictorially, I can put this way. If it is if whole of this area is machines, machine tools are some parts, these are machine that means I can call that all machine tools are machines, but all machines are not machine tool. Example of machine tool, as I told you, what we are seeing in workshop, lathe, milling, drilling, shaping, boring, all these machines are called machine tool. Then I come machining center. In any automated manufacturing system, essential criteria of any automated manufacturing system is lead time. Actually, this is the time between acceptance of the order from the customer and delivery of the product to the customer. And it has been observed in any production system at least 15 to 20% time is consumed for setting up the jobs. So, if I want to increase productivity and if I want to decrease the lead time, so that I can deliver the product to the customer as early as possible, I have to decrease the setup time. Say for example, let me explain this a bit further. Say for example, I have to produce a product which needs some, if it is a conveyor, if it is lathe machine, if it is say milling machine, if it is drilling machine, if it is boring machine. So, for this product first I have to set up the job in lathe, then once this lathe operations is completed, this job goes to milling machines, and once this operation is completed, this job goes to this machine, and so and so. That means, if I want to produce this product, I have to set up the job in each of the machines. If I want to decrease this time, what is the solution? The solution is that whether any machine is available where, of course not, some of the functions, most of the functions I should say, of milling machine and drilling machine and boring operations can be done on a single setup. Yes, this type of machine is called machining center. That means, in this machining center, I can operate or perform the operations of milling machines, perform the operations of drilling machines, perform the operations of boring machines. This type of machine is called machining center. That means, these are essentially machine tool, but very special type of machine tool. If I want to see this machining center pictorially, this comes this machining center. So, I can call all machining centers are machine tool, but vice versa is not true. Considering the cost of CNC technology, all machines are now machining center. If this operation, multiple operations can be performed in a single job, if it is a milling machine, then it is called machining center, and this machining center can be of course vertical machining center and horizontal machining center. If this same multiple operations perform in lathe machine, then it is called turning center. Turning center. Okay. Now, considering the cost of this CNC technology, now all machines are machining center. Machining center. Let me first describe control. That means, when output is not directly measured, just observed and action is taken care of, this type of control is called monitoring. And another type of control where output is measured and this is again this is called feedback. This is very frequently called closed loop control. Closed loop control, and this type of monitoring, this is called open loop control. Open loop control. Now, almost all machines today used closed loop control due to its better accuracy. As far as name is concerned, this numerical control machine, that means control is taken care of by some numbers. Initially, earlier version of CNC machine, there was numerical control machines. Where control actions are taken care of by directly numbers, but in CNC machines not only numbers, some alphabets also added like X, Y, Z, S, F, T, alphabets are used. That is why this numerical control become alphanumerical control. Alphanumerical control. Now, why I have integrated computer to these machines? Because of the fact I want to get a better accurate and precision jobs. If it is computer, if it is, you know, it is nowadays analog computer is not available. So, if it is computer, then I can expect that it is digital control systems whose accuracy is much higher than the any other control system. That is one aspect. Another aspect of this, advantages of computers, using computers. Basically, it can store huge amount of data. Not only that, it can retrieve within a very short span of time the file. That is why you see, if you observe in the market, brand new products are very few. Only things products are coming in a newer version, or that means if you have a programming on your machines, depending upon the features of the job, you can retrieve the program from the computer itself and just editing this program. That means advantage is twofold. First, I can store huge amount of data and retrieve within the very short span of time. At the same time, I can edit the existing program with a very less effort. That is why computer is integrated with these machines. Now, let us have a very formal definition of CNC machines. A CNC machine is an automated manufacturing process in which a machine tool is controlled in an ordered sequence along a predetermined path. Let me give you an example so that it can be understood. Suppose I have a blank, something like that. Now, I want to produce a job, I want to produce a job just a minute. I want to produce a job, something like that. My tool is here, my cutting tool is here. That means, if I want to cut, tool goes first to this one, then goes towards this direction, then goes this direction, then this direction. Again some depth of cut, goes towards this direction, goes towards this direction, goes to that. Then, so the sequence is very fixed. First this, then this, then this, then this. Now, you see, this machine goes to this, machine has to take decision, this movement is ceased, then this movement starts. Once the tool reaches this point, this movement along this direction is ceased, and again this direction starts. So, it is a ordered sequence, and in fact, it is a predetermined path. In fact, in any CNC machines, in any automated manufacturing systems, this path is determined by some coordinate with reference to certain origin. Okay. Now, this goes to this. Now, predetermined path to required dimensions, to specific feed and speed rate, and done through a group of alphanumeric instructions. This is a very brief history. So, in 1950 there was a, I have already told earlier version of CNC machine, there was a NC machine, that is that of course that was hardwired, no computer. Then CNC machine began with 1980. Then after 1990 it is open architecture control. Then 2000 onwards it is, we call it as we are using computers, it is soft NC machines. Like in any machine there are some standards, in CNC machines also there are some standards. Just for example, very few standards are given here. This is ISO 230 to 2006. This is what that is called test code for machine tools part 2 determination. Next is ISO 2806 1994 and so on. There are lots of codes is available, ISO codes. Actually you can't build a CNC machine, you can't design a CNC machine arbitrarily. There is some standard, that means which axis will be x axis, which axis will be z axis. In fact, in any CNC machines, job axis is z axis. So, these are some what should be the typical type of lead screw available. Now, this is an example of CNC turning center with 8 tools, with that means in a single setup 8 types of operation can be performed. Say that is a view of vertical machining center. If you see CNC machine, whenever you see in CNC machine in your workshop, it appears like a black box. You can't see what is inside there. Here I am giving you a exploded view of CNC machine, so that suppose it is a CNC machine is built with a perplex transparent material. Then what happens? You see here, you see this is a this is lead screw. Here 3 axis, so 3 motors are there. These motors are there. Every motors in there are a sensor behind, a sensor is there. This sensor is there. Actually, this sensors measures the actual positions of these machines, position of the machine, and it converts this actual position into electrical signal to the and sends this signal to the control systems. So, these are the exploded view of CNC machines. This is actually, you see, if you see any CNC machine, as far as components are concerned, conventional machine and CNC machine components are more or less same, except some, of course, some very important part, lead screw is there. These are the some specification and some technical specification. If you want to purchase this CNC machine, you need to give them this specification. So, in this lectures, what I have discussed what actually a CNC machine is, how it operates, what are the control technology, this in of course in a very brief. In the next lecture of CNC machine, I will deliver about the programming technique of CNC machines. Thank you. Goodbye.